Welcome back, friend. Hope you had a good weekend. I know we did some hacking last week on GHC, and it was a lot of fun. Got that PR pretty close. Got a few things to work on still, but today we're going to get back to where we were in our last project, the one we've been working on for a while now, the interactive fiction game engine, adventure engine. Got a few things to do, to work on. Some cleanup stuff. I still don't have like huge plans yet for object interaction. I think that's largely because like I haven't thought too much further about the game design. I have some ideas about the kinds of interactions I'd like to support, but I'm thinking tonight we're gonna take on some of these cleanup tasks, maybe fix the player render inventory, work on the save and restore commands because those will be important. And, you know, that kind of stuff. Sometimes that's what you got to work on. So that's what we're going to work on this week, I think. Thanks for stopping by again. It's always good to see you, to hack some Haskell together, to learn some things, have some fun, listen to good tunes, chill out, that kind of thing. And without further ado, what should we work on first? I think I want to work on the player inventory thing first. So that one kind of bothers me a little bit. So that is in here. So in the GUI is getting a little bit too touchy with the back end here, with the engine, and reaching in to use some of our kind of like internal engine functions to get state out of the game engine. And what I want to do is I want to expose the player's inventory as part of the state so it just can read the current state of the player inventory, not have to dig so deep into where it's digging into the game engine. That's right up in, I think, in here. The try render player inventory. All right, as we can see here, it's using run except here to like get inventory objects in reaching into the game engine, getting into the world object in the game engine, and so on and so forth. Which is fine. I just want to move this into like a simple accessor right on the game state where it's just got the current player inventory to render. That's it. So we're going to just shuffle some stuff around, I think, with this change. That's all I want to do here. With that being said, let's get going. Get some... Okay, so first things, I'm going to open up the engine here. Tataro. Okay, so the game state, let's see, the current player inventory is held in the world object, along with the player's current room and the verbs that the player has access to. Along with a bunch of log messages we want to log out from when things interact, which I guess is kind of a misnomer too. We should probably rename that. Kind of a small thing, but let's add it to our to-do. World log messages. Not really log messages, more like dynamic messages. Things that happen in the game world in response to the player taking some action. Right. So not really logs. Could be a quick little rename. That's about it. Yeah, so I think we're gonna move player inventory up into the game state. And we might also end up moving like the player's current room and the verb alias map as well. out of the world here. And leave the world to being just like a state of all the different objects and things in the world. So we're going to start there with the inventory first, though. So, let's see, I'm going to go over here and just get into Adventure Engine so we can fire that up when we want. Sorry for the beeps there. And engine, fire that up fast, file launcher. Now, I think last time we managed to get stack GHCI to work here. And Haskell process type stack GHCI is not that one, no. Stack GHCI bump there. Okay. Cool, so I can bump over there. Good. All right, now let's just take that right up. So one way we can do is we can move it right up to the inventory, or we can provide an accessor function that does the reaching in all the way to the world if we don't want to move it right away. And that way we don't have to like change the GUI code. It's kind of a smaller change on that part. And then if we want to move it around, we can move it around internally freely. I think that's probably the approach I'm going to take, actually. Just because that seems like a nicer way of doing things. My main concern is just that the GUIs reaching in here and using run except T. And then using like an internal kind of except T function to get in there. Right? Yeah. So ultimately, I need a function that goes from game state. That's the game state to a list of game objects. I should be able to do that, I think, without having to expose the run except T, the except T stuff. I think so. In fact, I might even be able to do that. Well, sort of. No, because the inventory, the way we're modeling the inventory right now, how are we doing that, by the way? It is a map that we add objects to, entity IDs, right? And get inventory objects. Looks up and traverses with get object from player inventory. Get object from the world. Right. So the map only has the IDs of the thing, of the object that's contained in the world. And so get object has to actually reach into the world database, find that object, because we want the actual game objects out, not just the entity IDs. And that's how we modeled the player inventory right now, which is why it's got to run the except T there. So let me just make this into a function and pull it inside. I'm going to just copy that. Like maybe player inventory. And pass in model, looks like, which we can do this point free now. It's really just the same thing. Now we'll get a type error, of course, because that's not defined anywhere. Let's put it in a where block here as another function. View player inventory. Right, just like that. Then we go W's. It should take a parameter. That's ultimately how we're going to do it. Let's see if we get that type error in the editor there. There we go. Still got those annoying ones, the keystroke stuff. So not super useful there. Could match type game state with world to const world, blah, 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 blah. And that's because... Why is that? It thinks the type's different than what it is. Than what I think it is. That's the problem. Yeah, so it wants game state. It's got this. Unexpected. What's going on here? Let me start over here. Okay. Try render player inventory. Right. Let's just cut this out and put it in engine. Say, let's just move it there. Barrel. This, and move that over there. Ah, yes, I see the problem. That makes it obvious. So try player render inventory was just using something that was like in a different scope. Legally, but just in that scope. So we need to get the game world out of the game object here, out of the model, right? That's odd though. I thought that would... Oh, that's because... Actually, is that because the lens is not defined in this file yet? Make fields. Game state and world. Yeah, they're at the end of the file. That's why that's not working. No problem. We don't really need it that badly. Let's call it game state. I'll just use the long name. Game state world. Game state. And of course we weren't using error anywhere, so we should probably use that. Yeah. Show that. Okay, so we move it into the engine. See, let's call it something more sensible. Call it get player inventory and replace that over in the GUI. So it's kind of like more of like an API kind of function for the GUI to use. But now that we have this function in place, we can move around the internal structure of the game engine data to be a little bit more suitable if we want, or we could just leave it this way. So let's imagine a world where the game state would have instead, because what I was originally thinking was like we would have game state, like player data. Right, like that. This would be some kind of structure here that would contain the player's current position, their inventory, things like that, and what verbs they have, their alias map as well. So that when we go to implement save state for the game, those are kind of like the things that are like really dynamic to scope this. The other thing that would have to serialize out is the world database as well, because we do change the world depending on how the users interacted with it. But it depends on like what we want, where we want to serialize out stuff. Because there's other things in the game state object record here that wouldn't make sense for implementing save states for the game. For example, we could save the rendered scenes so that if the user wanted to replay or reread through, we could save those. But like the input buffer, for example, and the game errors seem ephemeral as well. The world we'd want to serialize out as well. So I think it's just a matter of taste, really. I mean, if we implement save states like this, we could just ignore a couple of fields and just save this. And then when we go to like reinflate the game state from a save file, we could just populate those fields as well. Yeah. I think that kind of makes sense. In some way of putting all like the player data together. So I'm going to put a little to-do item here on this. And I'm just going to say, you know what? Might replace this. Into some kind of record. So that's what I would like the GUI to be able to do, is not actually have to like run anything in order to get this. And just have like the player's inventory kind of just there in a read model kind of thing, so that we just have to read the state. We don't have to do any computations to figure out what the current inventory is to render and stuff. But I also don't want to duplicate data all over the place and have to keep things in sync. So I think it kind of makes sense to do that. So we can have like a single function that when we go to add an item to the player's inventory, we get the game object out of the world database, and we can put a copy of that in the player inventory. But then we have one and the other, you know? But it does make it easier to read the data for the GUI. Trade-offs. You know, their inventory isn't going to be huge, so having a copy of the game object, one in the inventory just for display purposes, and one and the actual like game object in the map of the game world, not a biggie. Just a potential source of errors. Well, let's see if I like it. All right, what would that look like? Well, first let's just take a little checkpoint here. It looks good. Rename, try, render player inventory to get player inventory. And move that function to the engine. Okay, now let's see what this could look like. All right, get a player state. There's a player state. Could be player state room. All right, and just as if we were in the world object, or the world record, almost like that. And let's just rename those to player state. Let's derive eq and show, as you do. And then game state, player state would be a player state like this. Yeah. Okay, let's roll with it. Not too bad. 613. So we're gonna go just jump to the type errors. So they're gonna be pretty straightforward. So default game state, we need a default player state. Let's take that from the world, the default world. And I believe it's these three arguments. In fact, let's even remove those. That's a lot of code to update, actually. Let's leave those there. Let's create a default player state. Player state. And add it to the game state. And one more place down here. We just have to pop. And maybe one more. Okay, we're back to green again. Now it's not going to be very useful. We've just added that, but now we need to update all of the code that changes, say, the player's position to use the position in the player state instead of in the world. Which shouldn't be too hard, because I think we've localized that to a few functions. I think. Yeah, exit current room. Alright. Gets a room, just the current room. Gets an exit ID. Alright, that just gets the exit of the current room. Yeah, so like current room just looks in player room of the world. We'd have to get to the game state instead of the world, which is why I probably have everything in the world here. That's right. That's kind of a bigger refactor than we probably want to take on right now, because it's not really hurting anything to keep it the way it is. So, yeah. Do we want to get into this right now? I don't think so. I don't think so. I don't know. Let's look around a little bit more. So, for example, getting moving the room. Say current room. Current room is past a world. Exit current room is past a world. Get object current room is past a world. And like handle dig. Renders even past a world. I think it's because maybe it's because update game gets the world out and passes just a piece of our data to handle prime. Well, it handles the full game state there. The game state and world. All right, which parses the input. Let's see, gets the verb out of the player verbs from the world, handles the verb, the world. And this is probably where we're calling all of the little handler functions like current room and things like that. For example, in handle look, yeah, exit in current room, exit name, look in container, handle drop, right, gets a world, and all of that stuff. Because handle verb only gets a world. So it wouldn't be a huge refactor to change this to game state from world. And then these verb handling things can access the player stuff that way. Or the smaller thing we can do, the smaller change, is that the world can have the player state. We can just bundle all this stuff up into one type and just provide accessors for that. Yeah. Or what else is there? Yeah. I'm going to back out of that for now, I think. I feel like we're just noodling with that and moving data around, but it's not really going to change anything a whole drastically about the game engine in any way that seems important or useful. Okay. But we achieved the main goal there, which is just getting that function out of the GUI itself. The UI isn't running control.monad_accept. Now I think control.monad_accept is no longer necessary to import here. Potentially. Yeah, so we can get rid of that. Which is what we really wanted. Good. Okay, so also get rid of monad.accept import. Sweet. Okay. Let us go to the to-do file and knock that one off. Okay. Do we want to start tackling the save command? Why not? Okay, let's try it. Let's give it a shot. Okay, so the idea of the save command is that when we load up the game, I mean, used save states in pretty much every video game if you've ever played one before. You might have persisted other kinds of data using different kinds of applications if you haven't played video games before. It's kind of the same idea. So if we load up the game engine here, all we want to be able to do is, say, pick up the shovel. All right, we see the player inventory here on the right. And we see that we're in the front yard. We can go in the front door. All right, walk front door. When I walk in there, I want to be able to give the special command save. Maybe save should take like an argument, like the file name I want to save it to. Foo dot whatever, or just foo. Right, and when I press enter here, what I want the game to do is to take the current state of the application as it's running and save it to this file that I give as a parameter. When I press enter, like, it clears out the input buffer and just maybe leaves a message, say in the error buffers here, that the game has been saved. Just to let the user know that the file has been written, kind of thing. And then, well, that'll be the first part. And then so the output of that, though, is that we'll have a file somewhere. We have to figure out where we're going to save this file. But we'll have a file somewhere that has that save state in it. The benefit of that will be that we'll also implement a load command with the same idea. We can load food game. When we load food game, if that's a valid file, a valid save state file, it'll start up the game. It'll set the game state up based on what's in the contents of that file there and set it to that state. That's pretty much it. You know, and I'm not too against, like, users, you know, save state hacking. You know, it's a common thing to do in video games that even don't allow it. People reverse engineer the formats anyway. So maybe serializing to JSON will be fine. And just making it easy that way. But we should be able to, like, save it and then load it back up. And so when we load it back up, we get back to this. We have the inventory in the right place. Maybe we don't have to save... Well, actually, we did want to say we wanted to save all the scenes. So the user could, like, read through if they wanted to. But then we have, like, their inventory there. They're in the right room in the game. You know, the game's loaded up with the correct assets. Just remember, this is going to be a hackable thing where an author can write different content for the game and just run the engine on that content and stuff like that. So, but yeah, so let's do save states that way. Cool. So one thing we can do, the first step we could do when we're implementing our save command, is that we need some way in the engine for reading and writing files. So, reading and writing files. Want to be able to designate that certain files can read files, certain files can write files, and then have like an interface for doing those actions. And that'll just make testing a little bit easier. Because we'll be able to do it in memory and be able to replace those implementations and not have to like do a bunch of IO stuff if we don't want to. It's not totally overkill. I mean, we could just do it in plain old IO, but it's simple enough that I think if we wanted to do like read file, right? Could be some kind of text section where you give the file name and then an IO text. We could have write a file, which takes some text and then just writes it out. File name, sorry, as you'd imagine, and just writes that file out. That's not right. What's going on there? Oh, let's do it like that. I don't want to put IO directly. Well, we can put the constraint on M. It should be able to do IO-y things. Right. All right, so now we have a read a file function. If we want to implement that for IO, it's pretty straightforward. Just read file, I believe. Oh, it wants string instead of text. That's going to be annoying. Well, my app uses mostly text for stuff internally, so we could just convert, I guess, in our implementation. I think we have T unpack. Or is it T.pack? Oh, maybe I was right. T.unpack. Right. And we want text back. Whereas read file returns that. So let's import qualified data.text.io. And then t.read file. Does that work? It takes a file path to IO text. Okay, well, let's just change our definition. File path. Let's do the same thing for write a file. That's a little bit more clear than text anyway. I don't think we even need monad IO on that. Yeah, I don't think we do. Okay, and then we could do an instance here. Write file. Now this isn't like, you don't have to do it this way. Right, there's no. If you don't feel like the extra boilerplate's worth it, then you don't have to do it this way. It's totally fine not to. Reading and writing files is a pretty common thing to do. And if you just want to do it in plain old I/O, totally fine. All this buys us is that we can put this as a class instance as a constraint on some functions. And so now we can have a function that has monad write file as a constraint on the M in our stack. And then we know that that function only writes files. Same with read file, right? We can tell our function that this function only reads files. It doesn't do anything else. Other than, like, if we have other things in our stack, maybe those things can do stuff with it, but this function here is only going to be able to read files, and that's it. It's not going to write any new files either, which with I/O you have to, you know, the world's your oyster, really, and you have to, if you're going to be writing testable code and stuff like that, you have to be prepared to handle all those things. Hey Alice, how's it going? Right, yeah. So, I mean, it's trade-offs, right? If you don't have to write this extra boilerplate in order to interact with files in Haskell, is all I'm pointing out. You know, if you want to provide like kind of a point where you can replace M with an instance that you can test things with in a fairly big monad stack, say, and you don't want to have to test with the file system, this is one way you can do it. Yeah, and effect systems do have kind of more general facilities for these sorts of things. That's a good point. So with this in play now, though, we can have a save file function in here that can read the game state and everything else and accept T, throw game errors and all that sort of stuff, and say read and write files. So where do we want to put that? Let's say it's all the world interaction stuff. Let's just put it under here somewhere. Special commands. All right, save game state. All right, now we can go monad read file as a constraint. We could take a game state, and we could do an accept T game error to unit. Pretty straightforward. All right, because this is the only thing we say about M now. You know, we can't use write a file in here. That would be a type error. What's that type error going to be? Well, first of all, can't match type unit with except T That's an I/O function, so we have to lift I/O that. All right. We have to like return some value here. We need monad I/O on here in order to use lift I/O. Oh, that's interesting, actually. I didn't expect that to type check. That's what I expected there. But I guess when we lift IO on it, it can do whatever it wants still because of monad IO. Interesting. This is the type error I was expecting, though. All right, we can't write a file unless we put monad write file on there. Now that should work. But no, this one's not. Okay, maybe this isn't working quite the way I want it to. Now why is that doing that? If I take monad IO off here. Can't deduce context monad M. We can add that, say. Left? Maybe just left. Okay, but if I try read a file, would that block it? That should... Okay, that does block it. That's good. Cool. Right, because we're lifting from M into our accept T context, so I guess the lift kind of makes sense there. Right. Write a file. Da-da-da. Now, if I move this up to here, can I imply that M is a monad by virtue of implementing this as a constraint? Does that make sense? Apparently it does. Okie doke. Right, and so the idea is if we wanted to write this with like a test dummy kind of write file thing for like in-memory testing or whatever, just make sure that we like serialize the right thing or whatever. We could have like an instance of monad write file or, I don't know, writer, if there was such a thing, or state or whatever. State is higher kinded, so it means like something like this, but it could be if there's a way you could, I'm just writing nonsense BS here, but you know, you'd have some way of implementing this in some kind of data structure. That app behaves like a file, then you can at least see, you know, what your code's doing under test. So that's the general idea there. And usual, we'll get to that. Maybe we should start with that actually. And we can write an instance of monad write file for text. Right, and this takes a file path, some text. Right, we have to return something in the list monad, which is going to pretty much ignore the file path. I just return text in there. Right, this is not the coolest instance, maybe. Let's see, yeah, maybe we can't quite do that. Another way, I was thinking monad writer, because like that has stuff, but I don't know if people still use that anymore. A monad writer was like a way to... It had a method called tell. It lets you kind of like emit things into a list like thing. It's a lazy structure, so There's a tell function. I can write stuff into it. Can't really do that. Don't think I have that in scope, so let's bring that one in. Monad.writer.lazy. Oh, is there a strict? Ah, cool. So writer, similarly, I think the similar to the state, if I remember, takes kind of like a parameter in here. So we could even map it like this. We're going to have like the file path and the text that was written to that thing. Oh, I got all that all of a sudden. Pop, 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 pop. Have path there. Then we have a hole here. We're expecting a writer back. We could just tell with our fpath and our text. Sorry, txt. I think that should work. Not quite. Couldn't match the type. List of file path text with tuple file path text. I don't know if that's quite what I want to do. So the W thing is some kind of monoid. Okay. I think that would work. And then for read file. And then you provide a separate instance for this one as well, where you can set up like some kind of stub file thing where someone can construct that under test, and then just make sure that the functions that read data from files can do expected behavior. This one could be just a state of stub files. Right, and this could be like read a file. We're going to leave that undefined for a second. Just go ahead and check out this type here. Stub read file. Might just be a type alias. For a list of tuples of file path and text. All right, and then for implementing this now, can ask for the state, stub files, ask. We can try and look in stub files for the data, and if it's there, cool. If not, we can throw an error. An IO error, as you would expect. Perhaps even file doesn't exist or something. So yeah, let's look up from data.list. And that'll be fpath. In stub files, nothing. Just text, and we go return that. Ask isn't its scope? What? Hmm. Interesting. Where did it go? Controlled, I'm gonna add a state. That's the one. Oh, get. Sorry, I was thinking of reader for some reason. So there's a couple of instances we can use for writing our code to test the save game state. Okay, so why don't we go ahead and do that then? Let's start writing some tests for this. Let's go to spec. Ooh, ouch. Yeah, I know I haven't written many tests for this project yet. It's just been kind of a thing. I don't know. Normally, I do write lots of tests for a lot of production code that I use, and I'm very like a kind of test first sort of person generally speaking. But this project was just kind of like a little side project that sort of grew organically, just for fun. So I haven't really spent a whole lot of time doing that, but thought it'd be fun to do it on stream. Why not? So we want test.hspec. We might need to add that to the package. And tests, dependencies, hspec. And hspec, we should be able to just do they just have a top level function. Well, yeah, hspec. So we're going to talk about the save game state function. Now, let's start with some context. Given the default game state, it should... What do I want to check first? It should serialize the list. What should the specification here be? This is why we write tests first sometimes, or at least why I do, and also just in why writing stuff down in general before you go to write the code is sometimes a good idea, because it helps you think about what your system is supposed to do, and then later, more importantly, verify that your software does what you think it does. Because that can sometimes get away from you pretty quickly if you're not careful and very, very disciplined. I think the idea with game state is that we should actually not just have the game state, we also need a parameter to tell us what file to save the game state into. So we should have a file path. You give me a file path and a game state, and I'll write out a file for you. Is kind of the contract, I guess, that I want to go for here. So it should save given a file path, should save a file. That's not very interesting as a test. Like, pretty trivial. If I write a file, does it create a file? It creates a file. I'm just testing the file out system here. given the default. Game state. It should serialize. It should save the empty player inventory. All right, so the next thing we have to think about is like, how do we know that that worked? All right. How do we know that that's true? That if we had a program that did this, how do we test it? That kind of thing, right? And I think basically what we're going to start with is the default game state. We're going to pass it to save game state. And then, we're going to start with a monad writer. Yeah. We're going to start with a monad writer. We're going to run our command with it, and then we're going to check it. All right, we're going to have to reach in there to what it wrote out. And we're going to have to inspect that, the string in there, the text in there, and make sure that it has the right stuff related to what we're looking for. Okay. So then we go run writer, exec writer. We just want the W. Now we're going to exec the writer. We're going to call that on save game state, which is an accept T. And it's going to take the file path. Just like say temp/foo, for example. And the default game state, right? And all of this should be, and we get the W out, this should be a list of file path to text. And so we should have foo /temp/foo. I'll say it should serialize to JSON. Maybe something like that. I'm just going to put something silly in there for now. I think stack test is already set up to run that by default with this default template. right. We don't actually do anything yet, so that should actually probably just throw a straight off error. But if I just give it a silly implementation like that, we should also see it fail. Why is... Oh, because this probably wants more than one argument. There we go. Yeah, fix that. Now it should run the... And survey says... Booyah. Okay. Yeah, because we have to import straight. Now, I don't remember exactly the details, but I think the reason why people don't use control.monad.writer very much or don't recommend it is because something to do with memory leaks. So be wary. I'm only using it in like a small case here in a test, not in the app itself, so memory leaks aren't going to really, probably aren't going to bother me too much. And that's because we have to depend on MTL as well. And the package, and the test module. Let's go back to packages. Skadoosh. Spadoosh. MTL, bazoom, bazoom. The magic words. Make a lick a high, make a honey ho. Compile. Yo. Okay. Wow. And don't have default game C. We gotta import some stuff here from our game engine. Import adventure.engine. There we go. Run accept T. Control.monad.accept. Get down. In fact, we might still have some problems with this. Read there. Probably. Yes, yes. Ambiguous type variables. Yes. Probably about right. Yeah. Go ahead. I mean, you don't really have to. Just don't. Ah, okay. Kadoosh, 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 kadoosh. Sure. Okay, there's our type error there. Okay, no instance for monad write file, blah, blah, blah. String, string. First of all, not strings. Text. Well, that's another real problem with this code. So is the this is a problem because so we have the order of these unwrappings. Wrong. Do we have that wrong? No. Just maybe mixed up. Maybe it should have been exec writer T. So we have no instance for monad write file for writer T. We should have a monad write file instance. Or, oh, because it's string string. It thinks it's string string. Whereas the literals here are potentially being interpreted differently. Look, maybe is that the issue here? So possibly adding a type annotation, as GHC is saying, might resolve this. Because it just can't figure out what we meant just by the literals alone. Cool. So then, I think maybe what we want is to get the result, executing that in IO, and result. Should be blah, blah, blah. Okay, that fixes those, and then we're just left with no instance for monad write file. Writer T, file path, text, IO. And then once we fix that, then this should work? Question mark? But I'm pretty sure that should be fine. We should maybe make this a writer T. Which needs an M. Which will need a monad M, constraint. And that should be happy. And our test code. And Still not convinced, maybe? Still not convinced. One write file, writer T, file path text. M. That. Do you need more convincing that that could be an IO? Come on, GHC, tell me. Still don't think there's an instance for that. Let's try that with monad IO. Will that convince you? Oops. What have I done? Well, still not finding our instance. So we just have to convince it to find that instance, or that we have to give the right instance definition in order for it to find it. Although it might just be, no, it is me, I think. No? Might be my GHC. Or at least the GHCI running in my Emacs here. We also need text. No, you silly goose. Get rid of that stack. Test. There we go. So yeah, it must be some weird state with stack here. And the GHCI running in Emacs, because that is about what I expected there. I was looking for this. So we didn't write anything, right? So we run it as a writer. And if we write a file at /temp/foo with some data, like we should see that in the results. We call write a file. In our code, here, we haven't called write a file anywhere, so it hasn't written anything. All right, if I actually try that though, write a file with some file path. Ooh, that's going to be obviously incorrect. Some random hash data I'm going to put in there. And I'm just going to return pure and, you know, properly compose this together. And I try running this now. Now we should see /foo with blah, blah, blah in the output of running that writer. And that would be a good little step. All right. Instead we see, so we see like /foo blah, 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 blah. All right, and that's what we expected there, because we put in stuff. So if we take that out, no file's written. We put that in, file is written, and GHC is just selecting this instance for us based on the context that we've written our test term, the term of our test code in by calling it with exec writer t on it. So after we run except on this function, save game state, because it returns an except t, it returns this kind of m in the middle. That m we're interpreting as a writer t because we're writing except writer t, or exec writer t. So GHC goes, oh, I have an instance for this m that's also a monad write file. It has to be a monad write file. It has to implement that, which it does, for this monad, which it does. And so it calls this write a file implementation here. And so now when we want to test this in memory, the test code, pretty straightforward, right? We didn't have to go look up some files in our test code and touch the file system. We're just doing this straight in memory. So our tests will remain pretty fast. It also means that we can do simple stubs and things like that for the read file instance that we saw, that we wrote as well, and things like that. So that's the general gist with that. So now we can write tests around our save and loading of the game state and make sure it has the right spec that we want. And hopefully the test will remain nice and fast to use, and test code should be pretty straightforward and nice to write. So that's kind of one of the advantages you get from going down this route and choosing to use this bit of boilerplate and this little abstraction. Yes, it can be kind of overkill. Sometimes you just want to use monad IO and that's fine, or you just want to use IO and that's fine. So I'm just showing different things you can do, and I'm just choosing to make that trade-off for Adventure Engine. Partly for pedagogical reasons, partly just because I think it's a fine amount of boilerplate for me. So yeah, that's that. So let's actually like assert something useful now. What the? Oh, these are just suggestions. A redundant bracket. Yes. Do I need that type annotation still there? Or is it happy with this now? It still needs a type annotation there. Anyways, forget the lints, it's just test code. It doesn't have to be super awesome right now. Okay, so result should be, so if we give the same game state with like foo, well, file path, should it be any arbitrary file path, or if they give us some kind of file path, we, like the game engine itself controls like where that path should be. Meaning like our user shouldn't be able to like save and then overwrite some file by accident, right? They could give us a file path. They could just give us a file name. Like say foo. And probably should have something here like /dot adventure engine /saves /foo. All right, so we'll control the game engine will control this prefix where it saves user data, the user's home directory. This isn't super cross-platform, of course, but hopefully the file path stuff in Haskell, I'd have to look that up and takes care of that, but it's fine enough for now. The gist of it is that we should have some kind of reset path to save the adventure game engine data that it creates. Hopefully in some cross-platform way, if that's kind of our goal with the engine. To foo like this. And so we can go and make sure that it actually saves things at some kind of predefined path like that by actually hard coding it in here and concatenating on the parameter we get, the file path parameter. Comme ça. No, there. Like this. And file path comes from base. And here's a fun little application. If you haven't seen it before, Zeal is kind of a clone of a macOS app that I used to use when I was on macOS. Lets you do offline documentation. I should probably use it more. But it's very handy because you can keep your docs offline. So if you're on the go, on a laptop, it can be really, really handy when you're like hacking on the train. And so anyways, file path, path separators, so on and so forth, has system.filepath, .posix, for example. And I think there's system.filepath. If you import this, it'll hopefully load the same interface, but with the platform dependent code that you need for that platform. So we can go to the engine, system.filepath. I don't think we even need Haskell line anymore. Actually, file path should be there. And when we go to here for the file name, all right, and then this could be like our prefix, which is like adventure engine. That, I think that's the operator that it provides. So just replace extension, add an extension. Combine file path, yeah. With the platform dependent path separator. Cool. Kind of the gist of it, so let's run that. Oh, member of hidden package file path. Okay. We just have to add it. Here. File path. There we go. And in fact, now that we're running tests, we should run these constantly, fast in the background. Cool. So we got the first part right. Now we just have to determine what the JSON that we expect of the default game state to look like. And what the save state file data should create when we serialize the default game state. That's going to have to be for part 2 though, because I'm running out of time here for the stream. So we'll see you next week. Tonight, let's just start recapping. Kind of in an interim state here with the code, but so I won't check it in just yet. But look out for it anyway. I'll finish this up at some point this week. So the gist of it is that we're starting to add file save states to the game engine. We created this kind of tiny little bit of boilerplate here with monad read file, monad write file, so we can separate out those actions and provide fake implementations for testing purposes. And that will kind of let us just test the code, keep our tests nice and fast without having to touch the file system. We could if we wanted to, but then we have to like manage cleaning up after the tests have run and all that sort of stuff. So let's just do it in memory. So we did that using a little class and created instances for like IO, an instance for writer T. That's going to be like our test instance. Read file and the same kind of thing mirrors the two. And so when we get to the being able to actually implement save game state, we're going to be able to save your game state, write it out, run it under test, see that it works, and kind of expect that when it works with a real implementation with IO, it's going to basically end up the same thing. All right, so you still need some kind of integration test at the end of the day when you choose to go down this path of kind of abstracting out some of your interfaces to your file systems or databases or web services and so on and so forth. But you should still be able to spec out things and keep your test running pretty quickly using a method like this. So, well, that's that for this week. Catch me next week, of course. Same bat time, same bat channel. And may all your monads be free. May your types always check. And happy hacking in Haskell out there. Of course, join the Discord server too. And then we can chat more about the game engine, about your projects and what's going on. Peace out.